Hello everybody, welcome to the Go language course. In this video, I'm going to discuss the use of channels in Go language. Before I start the discussion, I have to include the main package on the first line of the program. So I have to say package main on the first line. And also I have to import the fmt package so that I'm able to use the print-line function coming from this package. Okay. And now let us go to the discussion of the channels in Go language. So what is a channel in Go language? We use channels for the goroutines to communicate with each other. Okay, we rely on channels to let the Go channels communicate with each other. So how can we make up a channel? So first we can make an unbuffered channel by using the make keyword, the chan keyword, and the type of the value to communicate. And I will show you an example to demonstrate this use of unbuffered channels. So the word unbuffered here means that there is no size limit for the channel. So the channel can contain as many values as you wish, and a memory address will be allocated to act as the channel. So the so-called channel is actually a memory location that stores the content to be transmitted or received. So how can I make a channel? I can make a channel by using the make keyword followed by the brackets, and in the brackets I have to say the chan keyword, which means channel, and the data type to be transmitted through this channel. So, for example, I want to transmit a float64 data type through the channel. So I have to assign the channel with float64 here, okay. And the channel is set up. And after that, I can show the channel type and the value of the channel by using the %t format specifier and the %v format specifier. So let us see the result of running this part of the code for now. Okay, you can see that I can print out the channel type, which is channel corresponding to a data in float64 data type. And the channel value is just the memory address that acts as the channel, okay? Let us see another example of the channels in Go language. So we can send and receive values via the channel. So what does it mean by this sentence? Let us see the example later. And in goroutines, we can send the values to the channel, and then we can retrieve the value after running the goroutines by means of the channel again. So I'm going to use two channels to demonstrate the receiving and sending of data via the channel. So I make channel 2 here and the channel 3 here. Channel 2 will be transmitting a data in string format, and channel 3 will be transmitting a piece of data in int format, which is an integer. And then I can make use of an anonymous function in the main function to send the data to a channel. So now I have a certain anonymous function, and I'm going to send a string to the channel. Okay, so I use something like an arrow symbol to make the string passed to the channel. Okay, so that is the sending action. Okay. In addition to using an anonymous function to send the data to a channel, I can also use a named function to pass a channel. So I will show you how to use the sendInt function to do so. So let us discuss the major idea first before I go back to the function to see the content of it. So we can send data to the channel by using a named function, and this sendInt goroutine would retrieve this data sent by handling the passed channel. So this goroutine called sendInt will pass a channel to it, and the channel will be receiving some data after the declaration on the previous line, and then when this goroutine is executed, it is going to receive the value from the main function, okay? And after the sendInt named function or the named goroutine has sent the data to the channel, we can make the print-line function to receive the content coming from the channel. So I have to use the arrow symbol followed by the channel name so that the value contained in the channel can be received by the print-line function. Okay, so let us see the sendInt function. Okay, this is the sendInt function shown here. The parameter of it is of channel type, so you can see that the ch here is meaning a channel that receives an integer, so I have to say int following the chan keyword, okay? and the channel would provide a value to do the further operations. So the send-in function is here, which will become a goroutine, and this goroutine will try to receive a channel called my channel 3, and my channel 3 is going to send a value called number 7, and when this channel has got the data, the send-in function, which is in the form of a goroutine, would be able to receive the data passed to the channel. So you can see that I use an arrow symbol followed by the channel name to just receive the data. So the data will be stored in the variable I, and after that I'm able to show the content of the variable I, which is obtained from the channel. So the channel has received something, and that data will be shown up in the printline function. Okay. So let us see the effect of running this part of the code. Yes, you can see that I'm able to do the sending of 7, which is in the form of an integer. So this means that I'm able to execute the goroutine called send-int, okay? And when the goroutine has got a channel that has the sent data, it can be passed to the send-int goroutine. The data will be received by the send-int function, and that value can be printed out. So you can see that the data can be printed out here. And at the same time, I also run the anonymous function here. So I want to pass the value called hello world into my channel 2, and my channel 2 is also able to receive the content by the use of the printline function. So the printline function has received the data from my channel 2. Okay, so you can see that I'm able to receive both 7 and the hello world string. Okay. So let us talk about another type of channel called buffered channel. What is a buffered channel? A buffered channel has a specified capacity, as opposed to the unbuffered channel that doesn't have a capacity. Okay. So it means that the number of values allowed in a channel can be specified when we make up such a channel called the buffered channel. So how can I specify the capacity? I can just use the make keyword followed by the chain keyword and the data type to be passed. And then I add a comma followed by the number of values that can be stored in the channel. So that is the specified capacity here. Okay. So it means that my channel 4 is able to store 2 pieces of data. Okay. So when I send 7 to my channel 4, it is able to do so because I've only got 1 piece of data to be sent to the channel. And I can also set another piece of data called 3 into the channel, because after doing so, I just used up all the capacity in my channel. So it means that I'm able to store these 2 values in the channel. Okay. So if I print out the content stored in the channel, I'm able to show up 7 first, because 7 is the first value passed to the channel. So after getting the received data, which is number 7, I will have number 3 remaining in the channel. And when I do the receiving again on the second printline function, I'm able to show number 3 again. So after these 2 printing actions, I'm able to receive all the 2 pieces of data from the channel already. And after that, the channel will become empty. So let us see the result of running this part of the code to see how I can get both values from the channel. So you can see that I'm able to get 7 first, followed by 3. So number 7 is the first value passed to the channel, okay? So that value will be received first. And the second value sent to the channel is number 3. That's why I'm able to get number 3 after getting number 7. Okay, and after that, the channel is empty, okay? So it means that I can accept only 2 pieces of data in the channel, okay? When we have multiple goroutines to use the same channel, the goroutine that finishes earlier would determine the data to be received. And the main function would get the earlier value received and ends the program straight away. And the main program doesn't wait for the slower goroutine. So it means that I'm just allowing the faster goroutine to execute, and if the main function has finished all the code, it doesn't wait for other Go channels to finish. So let us see this example. I have a channel called my channel 5, and that is a channel that is going to transmit an integer. Okay, and here I've a certain anonymous function, And the anonymous function here is going to sleep for 2 seconds before sending a number 8 to the channel, okay? And another goroutine is like this one. It just sends the data without sleeping, okay? So you will expect that I will get number 3 first, and then the main function would end. That means I'm not able to see number 8 coming out. So let us see the result of running this part of the program. Yes, you can see number 3 only. The received data is just 3. So it means that when this anonymous function or the goroutine is finished, the main function would just stop without waiting for the other goroutine to finish. That's why I'm not able to see the number 8 coming out, okay? So let us talk about the blocking of a channel. So it means that a channel can be blocked. So what is the meaning of blocking? It means that the channel will be stopped when it sends data, and the channel will be open again when another goroutine, including the main function, would consume the data. So it means that when I send data, the channel will be stopped, and the channel will be open again when another goroutine would try to consume the data or use the data. In another situation, a channel is also able to be stopped when it receives data, and the channel will be open again when another goroutine, including the main function, is able to send another data, okay? So when we have some receipt and the transmission of data, the channel will be stopped. That means the blocking will be executed, and the blocking will be stopped when the corresponding action is complete, okay? So let us see this example. I have a channel called my channel, and I have to use the make keyword followed by the chan keyword and the data type to be transmitted through the channel. So now I have a goroutine, which is an anonymous function, and this channel will be blocked until the main goroutine would receive the value. So what does it mean by this sentence? Now I'm going to send 5.3 to my channel 6 through this goroutine, okay? So this action of sending the data to the channel will let the channel block. So the blocking will be lasting for some time until the data in my channel 6 is received by another goroutine, including the main function. So when the data is sent to the printline function, the channel will be open again, okay? And at the time of receiving the value coming from the channel is also blocked, okay? And at that time, it is unable for us to use the channel to do anything, actually. And after the receipt is complete, the channel will be unblocked, so the channel can be used again, okay? So when we send the data and when we receive the data, the channel will be blocked. That is the major idea of this illustration here, okay? So let us try to run the program. So you can see that I can get the number 5.3 from the channel, and at the time of getting the data from the channel is blocked, and at the time of receiving the data by the printline function, the channel is also blocked. Okay, so we have to realize the situation that can make the channel block. Okay. Let us talk about another scenarios of the channels called deadlocks. What does it mean by a deadlock in Go language? When goroutines are blocked and unable to proceed, there will be a deadlock. Okay, and the goroutines will be waiting on each other. So what does it mean by the waiting here? Let us see this example. For example, when there are more transmission than receipt, a deadlock can occur. Okay. So let us see this example. I have a channel here. I want to send the data to a channel, okay? But you can see that the printline function after the sending of data to the channel doesn't receive data. So you can see that the data cannot be passed to the printline function. So it means that we have a deadlock. This means we have transmission only, but we have no receipt in this case, okay? The transmission is here, and the receipt is nothing. Okay, so it means that we have a deadlock in this case. Okay, so let us see the result of running this part of the code. Okay, you can see that I have a deadlock here because the sent data cannot be received by other functions. Okay, so that is the meaning of a deadlock. So we have another situation to produce a deadlock. When a buffered channel has more receipts than transmissions, a deadlock can also occur. So let us see this example. Now I have a channel called my channel 8, and the capacity of it is 2, okay. And I've already put 2 values into the channel. And of course I'm able to receive those 2 values from the channel. And how about the third receipt if I want to do so? The third receipt will lead to a deadlock because there is no sender responsible for the third receipt, okay. So the first 2 receipts are already done here, okay. And how about asking for the third receipt? It is impossible because there are only 2 values in the channel initially, and these 2 values are already received by the 2 prenup functions here, okay. So in this situation, when we have more receipts than transmissions, we have a deadlock. So we will see the effects right now to see the response of the program when there is a deadlock in this scenario. Yes, you can see that we have a deadlock, okay. So you can see that when I have more receipts than transmissions, then I will have a deadlock, okay. So when a buffered channel is full, an additional transmission would also result in a deadlock. So what does it mean by this sentence? Let us see the following example. Now I have a channel called my channel 9, and this channel has a capacity of 2, okay. So it means that it can only accept 2 pieces of data. But now I have 3 transmissions, okay. And after receiving 1 value, the channel has lost 1 value, okay. So it means that I'm not able to collect all these 3 pieces of data because the channel will be full after getting 4.1, okay. So it means that it is impossible to have 6.8 stored in the channel, okay. So if I want to really store some new number, I have to allow the value in the channel to be received, and then we have 1 empty space vacated after the receipt, and then I'm able to store another new value, okay. So when I am able to receive 1 value, the channel has lost 1 value, and we have 1 more space for another new data, like 6.8 here. And then the channel is able to send the third input, okay. So it means that I have to really remove some content in the channel before I can add another new value to it, okay. So let me try to comment out the final transmission to run the rest of the code. So I'm able to see that I'm not able to do the transmission. So how about commenting out the final transmission? And then I'm able to print out the received float data, which would be 2.3 first, and after that I'm able to have 1 space remaining, and then I can just send another value called 6.8 to the channel. So it is allowed for me to print out the 2 pieces of data again, which will be 4.1 followed by 6.8. So let us see the result of running this part of the code. Yes, for the first receipt here, I'm able to get the first value of the channel, and after that I can have 1 space remaining. That's why I'm able to store 6.8. So after running this line of code, the channel will have both 4.1 and 6.8, and then the next 2 prenup functions are able to receive the remaining 2 pieces of data in the channel, okay. So let's see what would happen if I just insist on storing 3 pieces of data in the channel that has a capacity of 2 only. Let us see what will happen with the code. Yes, you can see that we have a deadlock, okay, because the buffered channel is already full. It is unable for this channel to receive the third quantity, okay. Now let us talk about the final part of the video about channels. We can use the range keyword on channels. What does it mean by this sentence? Let us see the following example. We can use the range keyword to loop over the elements in a channel. So when we have the data in the channel, we are able to show the data 1 by 1 by means of the range keyword. So for example here, I have a channel called my channel 10, and the capacity of it is 3, okay. And I'm going to store some integers into the channel. So I'm able to store 2 and 9, okay. And we can just close the channel even if it is not full of elements. So even though the capacity is 3, I can just close the channel by using the close keyword, so that the channel has only 2 and 9 respectively, okay. And after that, I can use the range keyword to loop over the elements in the channel, okay? And in order for us to use the range keyword, I have to really close the channel beforehand. That's why when I want to use the range keyword, I have to really do the closing before using the range keyword, okay? So you can see that I have a for loop here. I want to get the elements in my channel 10, and then the value is called element, and then I'm able to get all the received values in the channel by using the range keyword. So let us see the result of running this part of the code. Yes, you can see 2 followed by 9 coming out. So the 2 pieces of data in the closed channel can be received by using the range keyword, okay? So this video has discussed a lot of things about channels. We can make an unbuffered channel by using the make keyword and the channel keywords. And it is just memory address that will be acted as the channel, okay? And we can receive and send values to the channel, and we can have the sending and the receiving of the data to be done by the goroutines, okay? And also we can have buffered channels that have specified capacities. And we know that the goroutines that finish earlier will determine the received data, okay, when we have so many multiple goroutines running together on the same channel, okay? And we can understand the blocking of channels. When the data is sent or received, the channel will be stopped, okay? We have to know the deadlocks that would make the channels unavailable for receipt or sending, okay? There are 3 situations. When we have more transmissions than receipt, the deadlock can occur. Or when we have more receipt than transmission, a deadlock can also occur. And when we have a full buffered channel, a new transmission would result in a deadlock, okay? Finally, we can use the range keyword to loop over the content in a channel, and we have to use the close keyword to really close the channel before I can use the range keyword. This is the end of the video. If you have any questions about my video, please leave your questions on the comment section below the video. If you like this video, please give me a like and please subscribe to my channel. Thank you for watching.